Okay. Great. So my name is Anna. I'm the graduate program advisor for all of the in-person programs for civil and environmental engineering. So we created this little info session for prospective students interested in the graduate programs in environmental engineering and H&H. So welcome, everyone. We're gonna basically have the faculty do a little introduction to each of these two areas, and then we'll have time for Q&A at the end. And so with that, I will have Mike start us off with environmental.
Okay, can you see my slides right now? Okay, so my name is Mike Brett. I'm one of the environmental faculty. You'll probably be surprised to know this, but I'm one of the environmental faculty that's been here the longest. And representing hydrology and hydrodynamics will be Professor David Sheen, who's one of the faculty in our department that's been here the least amount of time, one of the newer faculty. So you have kind of two ends of the continuum here. Here's kind of the pictures of the main faculty in our environmental engineering group, and I'll talk briefly about some of the research areas, and I'll talk about the structure of our graduate program, the differences between the professional master's program, the research master's program, and the PhD program, and how you would track on those different programs, some of the classes that we have available to people in our department, and some of the places where our people commonly work. So I'll kind of go over what some of the individual research faculty interests are a little bit later on. So environmental engineering, we look at the effects of natural and human activities on the environment with the goal of protecting human populations and safeguarding the environment. And we're doing a lot of research on efficient and selective methods for removing contaminants from air, water, and soils, sediments, to reduce adverse effects on the environmental and human systems. We have courses in research in our program in air resources, drinking water treatment, environmental chemistry, environmental microbiology, wastewater treatment, resource recovery, environmental systems, site remediation, biogeochemistry, and even research on natural systems. I do research on natural systems myself. We have on average in the environmental group at any given time about 70 professional master's students, MS thesis students, and PhD students. And there is a very strong regional job market for the graduates. So I would say nearly all of the graduates from our program get really good jobs within a fairly short period of time. So one of the studies that's a real high profile study from our group that got really international coverage was a study that detected a very toxic compound in tire leachate that was extremely toxic for salmon that migrate up into streams. This was got press in all the major newspapers and got quite a bit of TV coverage, but it was a huge discovery because people had noticed for quite some time that salmon that return to urban streams oftentimes die before they even spawn. And it turned out it was one very specific chemical that they put in tires to make the tires more resistant to degradation from ozone. And so that's a very interesting study that came out of our department just a couple of years ago. We have different tracks in our graduate program. One track is a professional master's program where you pay for the classes. It's self-funded, which means that you pay credit by credit for each course. It's very flexible, and the structure is very self-directed. So we let you develop a curriculum that matches your professional objectives, like what you want to maybe do, like stormwater management, drinking water treatment, habitat restoration, wastewater treatment. We allow you to design a curriculum to focus on wherever you think you want to go professionally. It usually takes about 4 quarters. It's 42 credits, and so we usually advise people to take 10 to 12 credits a quarter. And it gets you out on the job market fairly quickly. An alternative track that some students do is a research master's degree. That usually takes about 2 years. This track is then funded by a project. It also requires that you write a master's thesis. So it takes a little bit more time. It gives you a research experience, which can be, very interesting and a great opportunity for many students. And then we also have a PhD track, and that is usually takes about 3 years post-masters. And so most PhD students also do the masters. That's, again, a funded track, which means that, the project pays for your tuition, it pays for a monthly stipend, it pays for some basic health care, things like that. You're not going to get rich off of it, but it'll pay your rent and it'll pay, for food and healthcare, and tuition, which is very important. And this is a very good track for people that see themselves as being interested in research or academic intensive careers. So if you want to go into a research agency, USGS, places like that, or NOAA, that would be a good track for you. One thing I want to throw out there is that, at least in the environmental group, probably about half of the people that apply to our program are coming from from undergraduate degrees outside of civil or environmental engineering. And if you come from outside of civil or environmental engineering, then we require students to take 2 classes, one in mass balance and the other in fluid mechanics. And the reason for that is that mass balance and fluid mechanics are core concepts in environmental engineering, actually in H&H as well. And if you have taken like obtained an undergraduate degree in science, you have not been introduced to these topics in depth, and they're very fundamental for our curricula. It's going to be assumed in graduate classes that you are already familiar with these topics. So we require that you take these classes, and these are junior level classes, which you don't actually get to count towards your master's degree, but you need to take these classes to really do well in the graduate level courses. Here's a sample worksheet of how you would map out a course plan. Each student has to fill out one of these, and there's different tracks you can take. Water quality and natural systems. We have an air quality track. We have water quality and engineered systems. People are doing stuff like habitat restoration. The other thing I want to point out is that part of the reason that Professor Sheen and I are doing this presentation together is that there's considerable overlap between the environmental curriculum and the hydrology and hydrodynamics curriculum. So you can also mix and match courses and even research areas between these 2 tracks. So we do a lot of work on contaminants and stormwater, urban water. There's legacy contaminants from, things like fire retardant applications. And this is an area that Professor Jess Ray does a lot of research on, stormwater treatment in urban systems. She teaches classes in environmental engineering, cover a wide range of topics, and she does also teaches classes in physical chemical treatment processes and stormwater management and treatment. We have a professor named Mike Dodd who does research on oxidation disinfection processes. So he does a lot of research on that and teaches a lot of classes on oxidation disinfection. It'd probably take me the whole 20 minutes to just explain these 3 slides, so I'm not going to try to go into them in any great detail, other than to say that he does a lot of research and teaches a lot on oxidation reactions, which are very important for water treatment. And so he teaches classes on urban water reuse. Is an important topic in environmental engineering. Students get opportunities to go to field trips to wastewater treatment plants and drinking water treatment plants in the region. We have another professor in our department named David Buttman who studies kind of the natural carbon cycle. Does some really cool field research in exotic places, especially these days a lot in Alaska. We have a big water research program that students can tap into at the university that's cross departments. And like I said, there's another slide about Professor Buttman's research, just looking at how material, and particularly he focuses on the carbon cycle and how the carbon cycle of aquatic systems is interconnected with the carbon cycle of terrestrial systems. He does some really interesting research up at field sites in Alaska, where there's complex wetland systems that are developing on top of melting permafrost. And so there's some really important climate change implications for the kind of research that he does and the courses that he teaches in our curriculum. Professor Korshin does a lot of research on issues related to environmental chemistry, and especially his specialty is corrosion. And he does research also on things like arsenic and things like the runoff from landfills. So his research areas, like I said, arsenic in engineered and natural systems, natural organic matter, which is this brownish, orangish stuff here, which is very important in drinking water treatment systems since it reacts with disinfectants. A lot of research in general in our department on emerging contaminants and heavy metals and stuff like that. So got to keep on schedule here. Here's a picture of myself. I do research on lakes, rivers and estuaries, and issues related to water quality. So water quality in lake, rivers, and estuaries is primarily related to nutrient inputs. If you have a lot of nutrient inputs, you have very high algal biomass, as seen in the upper picture. And if you have very low nutrient concentrations in a water body, you're looking at the optical properties of nearly pure water. So this pictures from two lakes in Southern Oregon. One is called Crater Lake, one of the most beautiful lakes in the world, and the other is Upper Klamath Lake, which is one of the most disturbed and polluted lakes in the world. And the interesting thing is that these lakes are only like 25 miles apart, and the water from the crystal clear Crater Lake is predominantly the source of water for the really nasty looking lake. So it's really a fascinating system. But I study, toxic blooms, hypoxia, approaches for restoring lakes, rivers, and estuaries. I have a big project modeling Puget Sound's sensitivity to nutrient inputs from wastewater treatment plant discharges. So I teach classes related to that topic, and also environmental engineering and environmental modeling. We have Professor Mari Winkler, who's a world-famous microbial ecologist who studies nutrient removal in wastewater treatment systems, amongst many other things, but she's a world authority on the nitrogen cycle in wastewater treatment plants. And so she teaches classes on wastewater treatment and microbial ecology as it relates to engineered and natural systems. Professor Korshin teaches general classes on aquatic chemistry for our graduate students. That's one of the required classes in our curriculum. And then we have various classes on physical chemical treatment processes, environmental organic chemistry, which is a specialty for Professor Dodd, who I already mentioned. I teach environmental modeling courses at the graduate level. And we teach classes on, advanced topics. So things like, advanced filtration methodologies and stuff like that for both drinking water and wastewater treatment. And we do have a faculty named Julian Marshall who does air quality research. So our program in environmental is very heavy on water. Hydrology and hydrodynamics is also very heavy on water. But we do have one very high profile faculty in our department that does air pollution research, and he does a lot of research on social justice and environmental inequities and exposure to air pollution, both within the United States and globally. One of I think the most important questions that people often have is what would happen if you get a degree from our department? And I just have a list here of some of the engineering firms. I'm was looking at my LinkedIn profile with my former students, and I just picked out 5 or 10 places that recent students have gone to. So they go to a lot of the environmental consulting firms in this region. So there's, like I said, a very good job market. A lot of people end up going to agencies as well. I would say probably maybe 70% go to to engineering firms, and maybe 20% go to agencies. But here's some of the agencies that our recent grads have gone to. Some work for City of Boston, FAA, various water boards, WashDOT, which is the Washington State Department of Transportation, Army Corps of Engineers. King County is a fantastic place to work. And so that right there is what I want to say right now. And I'll be happy to take, any questions you have after Professor Sheen has had a chance to show his, to do an introduction to the hydrology and hydrodynamics group. So I will go out of my share and let Professor Sheen show his much better slides.
Thank you.
Thanks, Mike. So, hi, everybody. My name is David. I use he, him pronouns. And let me share my screen here. As Mike mentioned, I'm one of the newer. Are people seeing my screen? Does that look okay? Okay, but I'm not in full screen mode. So I'm one of the newer faculty members in the H&H group, and I actually teach classes that bring in students from all across the civil and environmental engineering disciplines, as well as students from across campus. So this is my first time kind of representing the H&H group here, so do my best. Let's just dive into this here. So kind of just general overview for people who might not be familiar. Hydrology is a science dealing with the properties, distribution, and circulation of water on and below the Earth's surface and in the atmosphere. And hydrodynamics is a branch of physics that deals with the motion of fluids and the forces acting on solid bodies immersed in fluids in motion. And we offer courses in both of these, and we have faculty with expertise in both of these areas. So kind of a high-level overview. Our program, we spend a lot of time providing training on physical processes, including freshwater and saltwater processes. We provide a solid background about traditional hydrology and hydrodynamics. We teach a lot of advanced topics, including numerical modeling, environmental observations and monitoring, advanced surveying, some of the things that I teach. And we have several faculty who are doing kind of cutting edge satellite remote sensing work for NASA and for other agencies. We focus on growing challenges in the natural and built environment occurring globally. There's a lot of interaction between students and faculty. We're a really open collegial group, and there's also many opportunities to interact with leaders in the local professional community. We lead a number of field trips. I do classes with a lot of field work, and we do field trips to sites around Seattle. And seminars and professional meetings. So I figure I'm going to go ahead and play this movie. I don't know if people are hearing that music, but hopefully you can watch this.
Yeah, so I think we're not getting the sound. I don't quite know the fix on that though.
No sound. Okay.
Yeah.
So it's just like a nice beat in the background. It's just music. There's no audio. So this is
Okay,
Nicoletta
cool.
Christea. I can narrate. Maybe that's what I should do. Nicoletta Christea is a new research faculty in hydrology and hydrodynamics. Talk more about Faisal Hossain's research, thinking about these questions, public health. Faisal and others, we use many different remote sensing platforms. Yeah, my area of special expertise, snowpack and glaciers, oceans and estuaries, and these metropolitan areas, agricultural lands, dams and irrigation. The Pacific Northwest has it all. So I'm going to go ahead and stop that. So that video was actually put together by Faisal Hossein, who's one of our faculty members, and he has skills in kind of outreach, communication, and video production. In fact, I think I've heard him say if he wasn't a professor, he would probably go into become a professional filmmaker. So just kind of why UW? I did my PhD here at UW in Earth and Space Sciences and worked at the Applied Physics Lab and started here in Civil in 2018. So we have a critical mass of expertise here, both in our department and all over campus. You're going to get exposed to cutting edge research, again, in our department, but as well as other departments on campus. We have broad network with alumni and other partners. And there's a regional demand for trained engineers here in Seattle and the broader Pacific Northwest. And, I don't know if people here live in the Northwest, but it's gorgeous. It's one of the reasons why I came to graduate school here. It's an outdoor paradise and it's an amazing place to study water. Yeah, a few takeaways. H&H, we're working to build an exciting, inclusive, diverse environment where we can teach and learn from each other. We do cutting edge research that improves our understanding and impact on society and the natural environment. So we focus on all aspects of the water cycle, management of water resources, in particular focus on the impacts of climate change. We use big data, remote sensing, modeling, and novel observations. So some of the classes I teach, we work on data engineering and data science, critical skills that you're going to need wherever you go after your graduate program. So I wanted to quickly run through, here's our kind of panel of headshots. This is the current faculty. So this is Bart Eischen. He's actually our department chair now, but he's also a surface water hydrologist who develops and uses hydrologic models to study the impacts of climate change on the hydrologic cycle and water resources. He's done a lot of very large kind of numerical modeling simulations and hydrological simulations for rivers, ocean simulations, entire continents. Jessica Lundquist, she studies snow and mountain hydrology, although she told me today, she's like, tell them I'm really interested in clouds. So Jessica is our resident snow hydrologist. She does amazing research, remote sensing, snow modeling, and other kind of water resource applications. I'm going to pause on Faisal because he has another video here. I'll let him introduce himself. This is Becca Newman. She leads the Hydrobiogeochemistry Research Group, and she does research on contaminants like arsenic and how they interact with soils, groundwater aquifers, and surface water. I'm David Sheen. I do satellite remote sensing, and actually we work with NASA primarily. We're working to build the next generation of satellite instruments to measure glaciers, snow, and water on planet Earth. We also think about what natural hazards, and we use a lot of drones and do a fair amount of field work here in the Washington Cascades. We go up to glaciers, try to measure snow depth in the mountains to understand kind of water resource levels for the river systems here. David Buttman, Mike already mentioned David Buttman. He's part-time faculty in the School of Environmental Forest Sciences, but then is also part-time here, teaches a advanced remote sensing class, and thinks about freshwater lakes in the Arctic. So a little bit of overlap in kind of my polar research. Erkan Istanbuloglu, so these are kind of the hydrology faculty. Down here, these are the hydrodynamics faculty. So Erkan is a numerical modeler, has done a lot of work with the Land Lab, Python kind of landscape modeling and hydrologic modeling package. Teaches a number of the kind of physical hydrology courses in the department. Alex Horner Devine, he studies the fluid mechanical processes that are responsible for transport and mixing in rivers, estuaries, lakes, and the coastal ocean. Christy is actually our newest faculty member. It was me until she joined us a couple of years ago. She's a coastal oceanographer. She studies coastal processes during storms to understand long-term coastal change. She does laboratory experiments, thinks about sand and wave transport, and numerical modeling of coastal flood hazards. Does a lot of big data and machine learning as well. Jim Thompson is at the Applied Physics Lab, teaches a few classes in civil environmental engineering, and he measures the ocean and sea ice using custom buoys and autonomous platforms, among many other things. So Jim goes on Arctic excursions up to study sea ice and the polar oceans. And Morteza Darakti is also one of our newer faculty members. He's also at the Applied Physics Lab, and he does coastal engineering and computational fluid dynamics. So a lot of kind of advanced numerical modeling. So all these faculty teach courses in our department. I'm going to go ahead and let Faisal. So you were saying the sound wasn't working, huh? That's too
No,
bad.
it might. I wonder if you go to audio, I'm trying to think. You might be able to fix it changing the audio settings.
Okay. If it's
Share
too much,
screen. Let's see.
David, can you hear the video when you're running it?
I can, yeah.
Can, okay, interesting.
Yeah, the other thing, yeah, we can also try like just dropping a link in the chat and just like pausing the recording and giving everyone a minute to watch. I don't know.
Okay.
Whatever you think is best.
All right. Yeah, so Faisal, so you guys can't hear anything?
No.
Okay. All right. Well, Faisal, our resident filmmaker, I will paste this link in the chat here. Of course, that's not working there. Faisal does a lot of amazing research and also works with partners all over the world to develop new tools and approaches using satellite remote sensing to make, well, to inform like farmers and think about food and our healthy planet. He works with many amazing students and collaborators here, thinking about sustainability, energy, water, and food resources, as well as flooding and other natural hazards. So I'll let you watch that link at some point, and yeah, we'll leave it at there. So I think I'll re-share my screen here. So we've talked a little bit about flooding and kind of natural hazards. This is a big deal. It permeates all areas of hydrology and hydrodynamics, and we have a number of faculty working on these. Here's a couple examples of flooding post Hurricane Harvey. You all have seen the news in the last few months with the 2 hurricanes that have come through in the southeast region of the United States. So very relevant, and also something that is continuing to change with ongoing climate change. So a lot of real need to understand these disasters. In H&H, you'll take courses and you will learn how to improve prediction of flooding and reducing flood risks. This is actually here in Washington State. This is not from a hurricane, but this is the Snoqualmie River, which floods every time we have really large precipitation events. We study hydrology, freshwater supply, and think about flood risks. So we do use numerical modeling. We think about snow and ice, kind of this is where I spend my time. But then do stream flow monitoring and also kind of energy balance and flux kind of balance calculations. Yeah, we'll keep going here. We use remote sensing to manage water resources and geohazards. The SWAT mission, Faisal is on the science applications team there. This mission is able to precisely measure surface water all over the planet with kind of millimeter scale precision. And it's changed the way we look at our freshwater lakes and river systems. This is a little closer to what I do. So basically we're measuring mass change, and this is groundwater depletion using the NASA GRACE and GRACE follow-on satellites. This is the Central Valley here in California. So we're actually able to detect kind of mass changes, very subtle mass changes due to groundwater pumping. A lot of great techniques to measure flooding from space with synthetic aperture radar. And then my group, we very precisely measure surface elevations using techniques like LIDAR and structure for motion and stereophotogrammetry to capture the mass balance of glaciers and ice sheets and other frozen systems. Civil and environmental engineers and H&H specifically study freshwater supply systems. This is Seattle. We have two main reservoirs. Our drinking water is amazing here, by the way. We have some of the cleanest, purest water in these two very large protected watersheds. There's a lot of infrastructure that brings that water to all the people living here in Seattle, and there are courses that kind of get into some of these details. I'm going to kind of keep moving through here. So again, all relevant questions. Civil engineers design experimental hydraulic models like laboratory systems. And we should say that, the department has an entire hydraulics laboratory with a number of wave facilities, flumes, et cetera. So there are courses, the hydrodynamics courses do a number of hands-on labs using this facility, and faculty and students are able to use this for research applications. Beyond the kind of lab experiments, obviously numerical models are a main part of what we do in civil engineering and specifically in H&H. So several courses use the HEC-RAS system, which is kind of a production numerical model for developed by the Army Corps of Engineers for a lot of hydrology applications. Okay, so Mike already mentioned the 42 credit hours. The H&H program is similar in terms of the breakdown. These are kind of shared common requirements for the graduate program. Here's our corresponding sheet. So there's a lot here. I don't expect you to absorb all of this. We actually just updated this today, so it's on our website now. We kind of have these core courses, and including kind of these four here. I'll talk about these in a second. And then the hydrology and hydrodynamics tracks kind of have these options, as well as the fate and transport, thinking more about the kind of environmental chemistry side of this. Yeah, and I don't think it makes sense for me to go through all of these, but this is kind of the core program. Data analysis, you'll get stats and learn how to do Python programming and Jupyter notebooks. Fate and transport, that's Becca Newman's class. Physical hydrology, ERCON is Dumbalooglu's class. Open channel engineering taught by Alex Horner Devine. And then one of these water management classes taught by Faisal Hossain. Within the hydrology track, there's a number of these electives, groundwater flow, GIS, so a lot of satellite remote sensing, Jessica's snow hydrology, another advanced hydrology class from ERCON. These two are mine, where we go out and learn how to fly drones and make very precise 3D measurements. And then this class is a data science kind of geospatial data analysis using remote sensing and sensor networks and other things like that. Other classes around campus and earth and space sciences and CEFS, the School of Environmental Forest Sciences, are also part of that track as options. Hydrodynamics, you're going to get more kind of numerical modeling, think about how waves propagate, sediment transport, computational fluid dynamics, turbulence, et cetera. So definitely more on the kind of physics and GFD side of things, but so those are kind of the electives there. And then fate and transport, I'm less familiar with this, but thinking about water quality, and I'll let Mike kind of answer additional questions about this track. So, just in a nutshell, what does this look like? Physical hydrology, you're kind of up here thinking about the water cycle. Data analysis, I guess, is out in the ocean. Groundwater flow is over here, thinking about aquifers and how water moves through the subsurface. Hydraulics of sediment transport, kind of surface level sediment transport within river systems. Fate and transport, thinking about the chemistry. And then water management, kind of big picture, how do we manage all these resources for the various water applications in a increasingly thirsty world. And then finally, some of these dynamics courses thinking about waves and coastal engineering. In the interest of time, I'm not going to go through each of these. I'll just leave them up for a moment. So if people want to watch them later in the video, just kind of going through some of the kind of topics that are covered in each of these core classes, kind of fundamental graduate courses in H&H. This one's mine. And then here's some of the geospatial data analysis where we're doing a lot of this programming, data engineering, data science, and data visualization. I'll also mention we have a weekly seminar where we bring in experts. Sometimes it's our own faculty, sometimes it's external faculty. Today it's Chris Franz, who's alumni, who's currently leading the large snow monitoring program for the Bureau of Reclamation. Another opportunity, this is a 1-credit course that is an option to students, or you can just sit in on the class if you don't want to take it for credit. But it's a great opportunity to hear about cutting edge research and what people are doing in these fields. And I grabbed those descriptions. Just a few other notes on kind of student life. So many of our students work and study while pursuing their graduate degree at the University of Washington. We try to accommodate that. We try to offer coursework on Tuesdays and Thursdays to allow students to kind of separate work from classes. Some students work full-time, some students work half-time. And there are a number of clubs, both within the University of Washington, but specifically within civil. There's kind of general clubs, the ASCE and other Engineers Without Borders, and then some kind of specialty areas, as well as diversity clubs. So not just for undergraduates, a lot of the graduate students engage with these. It's a great way to build community here. And Mike had the where do our grads go slide. So some overlap. A lot of our H&H students end up in consulting firms. Some of them end up in academia. They go on to pursue, a PhD, or they go on to look for faculty jobs. But a large portion of them get jobs within federal, state, and county agencies. NOAA. A lot of my students go work for NASA, the Army Corps of Engineers, USGS, as well as kind of King County and local state Department of Ecology and Transportation. So a lot of opportunities and a real demand, especially here in the Pacific Northwest for our graduates. And kind of the final point here is that, as a graduate student here, you're in this department and looking at, one of these environmental engineering or hydrology and hydrodynamics, but you're part of a larger UW community with, I think there's potentially, I think it's like 45,000 students now. And I think maybe 12,000 graduate students. And there's data science institutes, the Applied Physics Laboratory, other departments within the College of Engineering and College of Environment. So you're just kind of exposed to a lot of really amazing opportunities here at the time. So that's all I've got. Thanks for listening. And let me stop sharing my screen.
Awesome.
Happy to answer questions. Yep.
Yeah, thank you both so much. And yeah, for any of the students who are here, if you want to ask questions, feel free to do the little Zoom raise your hand function, or we can also use the chat, or I think there's even a Q&A box. So we'll go ahead and open it up. What questions do you have? I also have questions that we can answer, so we can start off that way. One question I get a lot from students, what can students do to make their applications stand out?
I can take a stab at it. So it depends on whether you are aiming for the research track or the professional's master's program. In the professional master's program, if you have a solid GPA from a strong program, you have a very high probability of getting accepted into our professional master's program. And then the core question is just how do you prepare yourself to be successful? If you don't come from an engineering background, you'll have different undergraduate classes than most of the people coming into our program. So you'll have to take this mass balance, fluid mechanics classes to kind of get caught up. If you want to do the research track, to stand out, what you really need to do is to make a connection with the person that you would most likely want to work with. And so you do research on which faculty are doing what sorts of research in our department, and then you decide who would you most like to work with, and then you establish a connection with that person. If you're in the Seattle area, by all means, try to meet them in person, try to, set up a meeting to go have a cup of coffee with them. We also have something later on in February called Visitation, where we invite in some of the people that apply to our program. We don't invite everybody, but we invite some of them and get to meet them firsthand they'll be here like a day and a half. So if that's possible, see if you can participate in that. But the most important thing is to link up directly with the people that you think you would like to do research with if you're interested in the research track. If you're interested in the PMP and you got solid grades, somebody like me or Professor Sheen will look at your application. And if you've got a solid background, there's a very high probability that you'll get accepted into our program. It's the matching up with a funded project is much more complicated because there's only so many funded projects, and everybody is looking for a prospective graduate student that's a really good fit for that particular project. And so each one's somewhat idiosyncratic. And I also say that the decision that's made on a funded research project is made by the faculty who is the leader of that project. We call that person the PI, the principal investigator, will make a decision on which student is offered funding from that project. Do you want to throw anything else in there, Professor Sheen?
No, I think that sounds good. I'm curious. Are the students? Oh, great, we have a hand up. So why don't we let
Go with the
Larissa?
hand.
Yeah.
Hi, can you hear me okay?
Perfect.
Yep.
Fantastic. So I noted during your presentation, there was a slide that mentioned that some students work full-time or half-time while pursuing their graduate studies in the department. So I'm actually sitting in a conference room at my office in Boeing right now. So I've been deciding whether or not to try to pursue the master's route or the PhD route, and was hoping you could give some background as to, is that just professionals, master program students, or if these were students also pursuing a research route, but we're taking it slow at first or something like that. Can you elaborate?
Yeah. So that slide was primarily targeted towards the professional masters. So often students will have employment at a local firm, and the firm will pay for them to come do a master's and advance their skill sets. In terms of being employed externally and doing a research track degree, it's not out of the question. Our students here, there are TA appointments and there are RA appointments, as well as fellowship appointments to support graduate students, as Mike had mentioned. There are, Mike, maybe you can comment on this, but I know that there have been students who have external funding who are working full-time and pursuing a PhD or a research track master's here. So it's less common, but it does happen, and students are very successful in that. They tend to be very focused and excellent students. So we welcome students interested in that.
Yeah.
Mike, I'll let you.
Yeah, I'll jump in. I'll say in those particular cases, it works when the student's professional interest and research project correspond. So they're working on something in our PhD program that's very similar to some core interest where they're actually working. Like, let's throw out a hypothetical. You could be working for the National Park Service on Elwell River restoration. And so you've been hired by the National Park Service to look at, the progression of the Elwell River restoration. And then at the same time, you're doing a PhD in our department, looking at something like maybe sediment transport out of the Elwha River catchment into, the adjacent marine system. So working and doing PhD studies works when the two are closely aligned. Like Professor Sheen said, probably the more common situation is professional master's students who are oftentimes working part-time, maybe 20 hours a week at a local engineering firm, and then taking coursework at the same time. And the advantage with the way our PMP is set up is that you can take as many classes, as many or as few as you want to each quarter. So you can balance, you can achieve a kind of a work, academic pursuit balance there by, varying how many courses you take each credit. Since you're paying by the credit, it doesn't cost you any more to complete degree going, half time than it would to complete it going 11 or 12 credits a quarter. Does that make sense, Larissa?
That does make sense. Thank you for taking the time to answer my question. I appreciate it.
Yeah, and if you reach out, there are students in the department who are working full-time and doing a PhD, so we're happy to put you in touch with them and they can tell you more about their experience. And I remember when I was starting and looking at PhD programs, I had a similar vision for myself, and I quickly realized that it was a challenging thing to do, and I ended up going to just a full-time or an RA appointment and focusing on my PhD research rather than trying to continue the external employment. So there's no set path, and we can help connect you with others who have pursued different options.
That'd be great. Thank you. I will definitely follow up afterwards. Yeah, I would definitely prefer to study full-time and research full-time, but depending on what I end up working on for my next project with my job, there might be something that aligns. And I like to keep my options open. So thank you.
Yeah, I'll just add on to say that as in terms of like degree requirements, we do have students who will come in and just do like part-time, and the big sort of cutoff is that you have to have your degree if it's a master's within 6 years, including like any time off. But yeah, we have students coming from all different types of situations, and we're usually pretty flexible as long as you fall in that like 6-year cutoff for the master's. Awesome. What other questions do you guys have? Anyone else feeling brave? Oh, Mike, did you want to say something?
Yeah, if nobody jumps in with a question right away, I'll throw out something that commonly comes up. And so a lot of times we get questions from people about the relationship between the professional master's program and the research tracks. And what I want to say about that is that, for one thing, you're taking exactly the same classes as each other. So you're working directly with the students in both tracks. And when you're in a class, you don't actually know what track your classmates are in unless they tell you they're doing a research project or they're working at a consulting firm at the same time. So you're taking exactly the same coursework. But the other thing I want to throw out there is that right now it's a very fluid system, because when the economy tends to be strong, applications to graduate school go down, and when the economy is weak, graduate applications go up. And so right now the economy is very solid for people with the kind of degrees that you have. And so we have fewer people applying to our graduate program, which means that there are a lot of students being recruited out of the PMP into the research tracks, into the PhD program. Like I manage, the admission of students into the environmental graduate program, and 2 of the students that just started this summer have already been hired on for PhD projects because, they had really relevant skills. Like one of them had skills in computer science, and she got hired for a project in H&H on sediment transport out of the Elwha River using artificial intelligence. And so she brought that, computer science expertise into our department, which is really beneficial. Then we'll teach her the hydrology and hydrodynamics and water quality issues that go along with that. So there are quite a few opportunities to go back and forth. There's absolutely no guarantee that if you start out in the PMP that you would be able to transition to the research project. And you may decide that that's not what you want to do anyway, but it's definitely a possibility. And these days there's been quite a few students that have gone from one to the other. And it's also happens because when we accept students into our program, we don't necessarily know how much money we'll have to fund students in the future. But when somebody gets a grant funded, and oftentimes when a grant gets funded, it's already kind of behind schedule because it takes a long time to usually work out the final agreement on a grant. People are looking for a graduate student in earnest. And so one place that they find graduate students is in their current classes. And if there's a really outstanding PMP student that actually is interested in research, that's a possibility to make that transition. And there are people that decide that the professional master's program is the right track for them because they'll get out into the real job market sooner than if they go into the research track. And so that they'll make a more rapid transition into just having, if they want to do something like work as a consulting engineer, it's a more rapid and a more seamless transition into the career track. So that's what I wanted to comment on.
Awesome. Thank you. Yeah. So I would just reiterating, I think there is some flexibility too. I spoke with a student today who went from the research master's to the professional master's program because of some life events. And just she just wanted to get it done. So there is some flexibility with that. And I think everyone's always working together to help accommodate students. I'm going to go ahead and drop in the chat the email address for advising. It's ceginfo@uw.edu. If you think of more questions, please reach out to us there. You can also reach out to the faculty as well. They have the faculty pages on our website. I always say, if they don't respond, don't take it personally. They're very busy. Try someone else. And eventually you'll get a response. And yeah, we'll be posting this on the webpage if you need to refer back to any of it. And thank you all so much for coming on a kind of crazy day. And we hope to see your applications. So thank you so much.